Welcome to our science lab. Today, we're diving into some mind-blowing experiments that you can try at home. Get ready to be amazed. We've got 5 awesome experiments lined up, each one more exciting than the last. But before we get started, make sure you've got a responsible adult nearby to supervise. Safety first, always. Now let's grab our lab coats, safety goggles, and a healthy dose of curiosity as we unlock the secrets of science together. Alright, science fans, for our first experiment, we're going full-on mad scientist and creating a classic baking soda and vinegar volcano. Now, this isn't your typical papier-mâché volcano. We're talking real chemical reactions happening right before your eyes. First up, grab your baking soda. This stuff is pure sodium bicarbonate, and it's just itching to react with something acidic. That's where the vinegar comes in. It's like the arch nemesis of baking soda, just waiting to clash in a fizz of epic proportions. When these two ingredients combine, they create a chemical reaction that releases carbon dioxide gas. This gas expands rapidly, causing pressure to build up inside the volcano. And guess what? That pressure needs somewhere to go, leading to an eruption of foamy goodness. But here's the really cool part. You can actually see the chemical reaction happening in real time. As the baking soda and vinegar mix, they transform into something new, releasing those telltale bubbles of carbon dioxide. It's like magic, but with a scientific explanation. So there you have it, the baking soda and vinegar volcano. It's a classic experiment for a reason, and it never fails to impress. Get ready to be blown away by the power of chemistry with our next experiment, elephant toothpaste. This one is messy, it's foamy, and it's guaranteed to make you say, whoa. At the heart of this experiment is hydrogen peroxide, a chemical that's itching to break down into water and oxygen. But here's the thing. Hydrogen peroxide is a bit shy, and it needs a little encouragement to get the reaction going. That's where our secret ingredient comes in, yeast. Yeast acts as a catalyst, which is a fancy word for a substance that speeds up a chemical reaction without being consumed itself. Think of it like a matchmaker for hydrogen peroxide, helping it to break down quickly and dramatically. When the yeast hits the hydrogen peroxide, it's like unleashing a chain reaction. The hydrogen peroxide molecules start breaking apart left and right, releasing a ton of oxygen gas in the process. And since we're using dish soap in this experiment, all that oxygen gets trapped in the soap, creating a massive eruption of foamy goodness. But here's the kicker. The reaction also produces heat, making the foam warm to the touch. It's like a mini volcano. But instead of molten lava, we've got a mountain of fluffy, elephant-sized toothpaste. So there you have it, elephant toothpaste, a spectacular demonstration of chemical reactions in action. Ever wonder why some objects float while others sink? Today we're cracking the code of buoyancy with a simple yet mind-blowing experiment, the floating egg. You see, whether an object floats or sinks depends on its density, which is a measure of how much mass is packed into a given volume. Objects denser than water will sink, while objects less dense than water will float. Now, an egg on its own is denser than plain water, which is why it usually sinks to the bottom of a glass. But here's where things get interesting. By adding salt to the water, we can actually increase its density. Salt dissolves in water, adding more mass to the same volume of liquid. As we add more and more salt, the water becomes denser and denser until it eventually becomes denser than the egg. And when that happens, something amazing occurs. The egg starts to float. It's like magic, but it's pure science. By changing the density of the water, we've created an environment where the egg, once destined to sink, can now triumphantly float on the surface. The floating egg experiment is a fantastic way to visualize the concept of density and learn how even small changes in a liquid's composition can have a big impact on its properties. Get ready to groove with the mesmerizing beauty of our next experiment, the homemade lava lamp. This experiment is all about exploring the fascinating world of liquids and their unique properties. At the heart of this experiment is the concept of immiscibility. which is a fancy way of saying that some liquids just don't like to mix. Oil and water are a classic example of immiscible liquids. No matter how much you shake or stir them, they always separate back into distinct layers with the oil on top due to its lower density. Now, to create our lava lamp effect, we're going to add a little something special, an effervescent tablet. These tablets contain ingredients that react with water to produce carbon dioxide gas, just like in our volcano experiment. When we drop the tablet into our oil and water mixture, something really cool happens. The tablet sinks to the bottom and starts to fizz, releasing bubbles of carbon dioxide gas. These bubbles attach themselves to blobs of colored water, making them lighter than the surrounding oil. As the gas bubbles rise to the surface, they carry the colored water blobs along for the ride, creating a mesmerizing lava lamp effect. The blobs of water rise and fall as the gas bubbles form and dissipate, creating a captivating display of fluid dynamics. Hold on to your hats, science fans, because things are about to get lit. For our final experiment, we're conjuring a mesmerizing vortex of fire, the fire tornado. But before we get started, remember, safety is paramount. This experiment involves fire, so adult supervision is non-negotiable. Now let's break down the science behind this fiery spectacle. A fire tornado, also known as a fire whirl, is a whirlwind induced by a fire and often made visible by smoke. They occur when intense heat and turbulent wind conditions combine to create a spinning vortex of flames. To recreate this phenomenon in a controlled environment, we'll be using a few key ingredients. First, we need a source of rotation. A lazy Susan works perfectly for this, providing a stable platform for our vortex to form. Next, we need to create a cylindrical enclosure to help direct the airflow. A mesh wastebasket is ideal for this purpose, allowing us to observe the fire tornado from all sides. Finally, we need a flammable liquid to fuel our fiery vortex. Lighter fluid with its low flash point and controlled burn is a safe and effective option. By carefully introducing the lighter fluid into the spinning wastebasket, we create a column of flammable vapor. When ignited, the flames are drawn upwards by the rising hot air, creating a mesmerizing vortex of fire. The spinning motion of the lazy Susan, combined with the rising hot air, creates a spinning column of fire that dances and flickers with mesmerizing beauty. The fire tornado is a captivating demonstration of the power of physics and the interplay of heat, air pressure, and rotation. Remember, always prioritize safety when experimenting with fire. Thanks for joining us in our science lab. We hope you enjoyed these experiments and learned something new. Don't forget to like, subscribe, and hit the bell icon for more exciting science videos. We had a blast exploring the wonders of science with you today, from erupting volcanoes to mesmerizing fire tornadoes. Remember, science is everywhere, waiting to be discovered. So keep your curiosity alive, never stop exploring, and who knows what amazing things you'll uncover. Until next time, stay curious, stay safe, and keep those science experiments rocking.